Let's take a look at a real-world problem involving exponential growth. The population of a town is estimated to increase by 15% per year. The population today is 20,000. Make a graph of the population function and find out what the population will be 10 years from now. First, we need to write a function that describes the population of the town. The form for an exponential function is y equals a times b to the power of x. As a review, a is your initial starting point, and b is your change, or in this case, your 15% increase. To calculate percents, it is necessary to change 15% into a decimal. 15% as a decimal equals 0.15. In order to get the total population for the following year, we must add the current population to the increase in population. The current population, that would be 100%. It is going to increase by 15%. So we're going to add 15% for the increase. Again, we must turn this into a decimal, so our decimal becomes 1.15. This means that our population must be multiplied by a factor of 1.15 each year. So our change, or our base b, will be 1.15, and we're starting with 20,000. That's our initial. Our formula for this story problem becomes y equals 20 for 20,000 where we're starting, times the change of 1.15, which again is 100% for the population now plus the 15% increase, to the power of x. Let's create a table of values that shows how the population will change year after year. Here is the table for the function y equals 20 times 1.15 to the x. We can see at the start, for 0 years, we're at 20,000. After 2 years, the population will be 26,000. Let's take a look at the graph. As we can see by the graph, the exponential function curves starting out with a slow change and increasing with a greater change. The question when we started was, what will the population of the town be 10 years from now? With the table of values here, we can see that the population will be 80.9. Remember that this is 80.9 thousand. So we can write that as 80,900. If you don't have a table of values in front of you, you can simply plug in 10 for our x. Y, the population, equals 20 times 1.15 to the power of x, x being the number of years. If we want to find the population after 10 years, we make that exponent 10. Plugging that into your calculator, you will get 80,911.